Okay, this example will show you on the steps to solve questions with that deals with fluid forces due to flowing fluid. Okay, now in this question, consider that you have pipes placed horizontally on a plane surface. Okay, so there's no height difference between your points along the pipe because it's placed horizontally on a plane surface. Okay, the pipes are connected with a 60-degree elbow given with the information as stated there, and the question is find the horizontal force exerted by the elbow and also find the vertical force exerted by the elbow. So we are talking about this elbow. So this is our control volume system. Okay, here is our control volume. So now what should we do is, because that is our point of interest, I will take out that part. So we have that elbow. Okay, 90 degree. Now that is our control volume. Now we have to label all the acting forces on our control volume. Okay, first of all, what you must have a pressure. Okay, you must have pressure element because it's a continuous pipe. Okay, inside a continuous pipe, you have a pressure, and the pressure by definition is always acting towards your control volume surface. So in this case, you will have F2, and that way you will have F1. Okay, but this doesn't look nice because your F2 is not in the X or Y component. So what you have to do, you expand your F2 like this. Okay, because F2 is the resultant of, in this case you will have F2 cosine 60, and here you have F2 sine 60. Okay, F1 you can maintain as it is because it's already in a horizontal direction. That is the first one. Second, you have to look into the velocity. Okay, the velocity in this case, the flow is flowing from your right hand side to your left hand side, so you'll have V1, and then it's leaving your elbow that way, so there you have V2. Okay, similarly, because it's not in a X or Y component, so what you have there, you have V2 cosine 60 for this X component, and then here you will have V2 sine 60. Okay, before that, please take note, I have defined my axis this way. You will have positive X if it's moving from left to your right hand side, and then positive Y if it's moving from downward to upward. Okay, so we have the force, we have the velocity already. Next, we need to find the force exerted by your elbow. In this case, first we assume Fx going that way, and then your Fy is acting downward. Okay, can I have my Fy acting upward? Of course can. Okay, it depends on your own assumption first. Later on, based on the final answer, if it's negative, meaning that it's not that way, it should be this way. Okay, we just have to adjust the direction based on the final answer later on. So we have completed our control volume diagram there with all the forces. Next, we go straight away with our question number 1. Find the horizontal force. Okay, so you are looking for the x-axis. Okay, so what you have to do now, look at all the forces acting on the x-axis. I will highlight all the forces acting on your left axis. Okay, so you have here fx, and then you have this one also x-axis, this one, and this one. Okay, so you have 1, 2, 3, 4, and 5 forces acting horizontally. Now we build the balance equation, the force balance equation. Fx here going to your right hand side, and we have defined anything go to that side, go to your right hand side, become positive. So positive Fx. Okay, next, second one. This force is going to your left hand side. Okay, but you have defined only going to right hand side, then it will get a positive value. So in this case, it become negative F1. Okay, and then you have here another one, force 2, negative minus F2 cos 60 equal to, and we look at the velocity components. Okay, in which the velocity component, the force is given by rho times with a v times with the AV. Okay, if you have a system, if it's entering a system, then your AV become negative. If it's leaving a system, your AV become positive. Okay. So in this case, we look into V1 first here. Okay, V1 is going to your left hand side. Okay, so you will have rho maintained without any sign, and then V is going to your left hand side, so negative V1 because go to left side. Okay, and then is here, this one, your V1 is entering a system. So when it's entering a system, what do you have there? You will have negative A1 V1. Okay, this is the force at control surface 1. Control surface 1. Okay, which refer to this control surface. Now look at control surface 2. You are now looking at this force V2 cosine 60. Okay, so what you have there, V2 is going to your right hand side, so density plus V2 cos 60. Again, become positive because go to right side. Okay, and then for your AV component, you have A2 V2. Okay, A2 V2 here is leaving your component, leaving your control volume or control surface, it become positive. So positive. Okay, why? Because it's leaving the control volume. Okay. Now, can we solve the equation? We look at individual parameter there. Okay. First, A1 is equal to A2. The same diameter, 10. What do you have there? You will have 0.1 meter and 0.1 meter in pipe A, also pipe B. So, with that, we know that from the equation of rho A1, V1 equal to rho A2, V2. This is the same, constant. So, V1 equal to V2. So, this is the first information. Second one, the velocity is given, kan? So, this is which 5? This is 5 meter per second. Okay. So how to find F1 and F2? Second, P equal to F over A. So you have F1 equal to P1 A1. Were you given the value for your P? Yes. Here, pressure at A and B is 80 kilopascal. So F1 equal to 80 kilopascal times with the surface area at A, which is pi 0.1 square over 4. Similarly, for your F2, you have P2 A2 equal to 80 kilopascal times pi 0.1 square over 4. Okay. Now, with this two information, you have your value for F1 already, F2. Okay. V1, because it's equal to V2, done. You have A1, you have V1 here, you have V2, you have A2, you have V2. Okay. This is the one that you need to find. So, your Fx. Substitute all the equation, you will get 1.21 kilonewton. And the answer is in a positive sign here. It's a positive sign. What does that positive sign indicate? It says that your assumption for the direction is true. Betul. Okay. In which you have assumed that your horizontal force is acting to your right hand side. That direction, kan? So that's the answer. So this is your final answer. So Fx, oh dear, you cannot see that color. Okay. Fx is 1.2 kilonewton acting to your right hand side. Now we go to the second question. Find the vertical force exerted by the elbow, which means you need to find the Fy. Okay, remember here, your Fy, you have defined your Fy based on your control volume diagram here. Your Fy, let's highlight all your your Y forces in yellow color. Okay, so 1, 2, which one you have? Okay, 3. Okay, you have 3 forces, 3 vertical forces. Okay, the yellow one. So what you have there, you will have Fy. Okay, now take note on the direction. You have defined your Y to be positive when it goes upward. In this case, your Fy, you assume that it's going downward. Okay, so it becomes negative Fy. Okay, and look at your, do you have any other any other force? Yes, this one. Okay, you have here F2. So it's going upward, so positive F2 sine 60. Okay, equal to, now look at the velocity component. Control surface 1. At control surface 1, here is your control surface 1. There is no vertical force acting on your control surface 1. Equal to 0. Plus, now look at your control surface 2. At control surface 2, here, this one at the exit, okay, you have two vertical forces, which are V2 sine 60 and F2 sine 60, in which this one we have covered that part, the force part here, the pressure part, okay, leaving you only the velocity component. So you will have density is going downward, so become negative V2 sine 60. Okay, we'll make a note there because go downward. Okay, and then your AV component. Your AV component, it's leaving your control surface. So A2 V2 plus. Okay, we'll make a note there because it's leaving the control surface. So F2 you can find, you have it here already. Okay, and then V2 you get it from here, V2 equal to V1. A2 also given. Okay, so you can solve for your Fy. So your Fy equal to, actually when you simplify that equation become negative density A2 V2 square sine 60. So you solve for that, your Fy equal to negative 697.18 Newton. Okay, here you get negative sign. Okay, what does it mean? Because you have assumed in the first place, you assume that your Fy is acting downward. Okay, okay, and this negative sign here can be cancelled out with this negative sign. So what you have there, you have Fy equal to 697.1 Newton. Okay, so it does not contradict with your first assumption saying that your vertical force is acting downward. So in this case, your final answer is 697 Newton, where the direction is going downward. That's the final answer.